after saponification. Now we've already studied two very important compounds of carbon, that is ethanol and ethanoic acid. But now, right now, we're going to study the most major important compound of hydrocarbons, soap. And I hope you're using that daily. Yes, I really hope so. Saponification, preparation of soap. How does this soap get formed? Reaction. There are three ways, or two ways I'll say. The first way is carbonates and hydrogen carbonates. So you can either use a carbonate to form soap or a hydrogen carbonate. Let's see. When acetic acid reacts with sodium carbonate, it forms something called as soap. So ethanoic acid and a sodium carbonate. Now you know that it is a basic carbonate. So therefore what happens is this acid and base will give you salt plus water. But because of that carbonate, you'll also get a carbon dioxide. So just imagine this reaction as the H from the acid being substituted by the Na. So what you get is CH3CONa. And the H goes with H2CO3, which is then further broke down into H2O and carbon dioxide. And when this happens in the presence of NaOH, the reaction is much better. So this sodium ethanoate is a group which represents soap. So this is not soap, but it is kind of like a soap. So basically, when I remove that ethanoic acid and use a larger carboxylic acid, soap gets formed. So how do you balance this reaction? CH3COOH, CH3COONa. You can clearly see Na is 2 and Na is 1. So you multiply it by 2. Now, what happens is CH3COO multiplied by 2. So therefore, there also you have to multiply by 2. And when that happens, H is 2 and over here H is 2, C is 1, C is 1, O is 3 and O is 3. The reaction has become balanced. CH3COOH plus NaHCO3. Now, how will you do this reaction? Exactly the same way. H will be replaced by Na, CH3CONa, and that HCO3 will be divided into H2O plus CO2. In the presence of NaOH, the reaction would be faster and better. CH3COONa, again a group, like it is a homologous series of soaps. But this is the most widely used reaction where an ester with the help of an alkali is turned into soap. But this soap process happens in two steps. First is hydrolysis of ester and the second one is reaction of acid with alkali. Now how does this happen? Please pay attention, all your attention. Hydrolysis of ester. Hydro, water. Lysis, breakdown. Ester is broken down with the help of water. So, CH3COO C2H5. The water from NaOH in the presence of alkali, the water from NaOH, that is the H plus ions and the OH minus ions, are used to break this ester. So the CH3COO will go with the H plus ion, making what? CH3COOH. And the OH will go with C2H5, forming what? C2H5OH. The first step is complete. Now the CH3COOH, which is there in this product, will react with the NaOH, which is just acting like a catalyst right now. So when those two react, you know what is going to happen is the Na is plus, it goes with the CH3COO minus. So what is formed is CH3COONa. And the H plus of the acid reacts with the OH minus of the sodium hydroxide and forms H2O. So in this reaction, you can clearly say a ester with the help of NaOH reacts to form these compounds. So the total saponification reaction can be summarized with the help of this. So the ester reacted with NaOH to form the first compounds were alcohol and carboxylic acid. But that carboxylic acid reacted with the NaOH to form two more compounds, that is soap and water. Removing water, what is left is CH3COONa plus CH3CH2OH, that is sodium acetate and ethanol. Now, why is this reaction very important? Because soaps are just like that. Saponification, when vegetable oil instead of ester reacts with NaOH. Now, vegetable oil also contains ester. NaOH, it forms a soap that is just remove the CH3 and put C17H35. So C17H35 COONa plus glycerol, which is also like ethyl alcohol. So that is why we studied this reaction in so much detail, because this is the exact reaction which is used for saponification. what is the difference between soap and detergent in the next module.